Hello and welcome to Sequential Mining for Fake News Data, project by Group 4. Today we'll be going over how we turned a sequential mining function, specifically prefix span, into a generator of sequences to which we could then feed into machine learning algorithms. While we talk about this program, I'm going to be running an example in the background, which you can see down here. It'll just chug away as we continue talking. So the first thing that happens is a little bit of data cleaning, which we'll go over later, but once that's all said and done, we start to do the sequential thing. Initially, we get an array of articles in string format. From there, we take all of the articles and we find a word map consisting of all the unique words in that entire input data set. Once we have all the unique words, we check to see if we need to do a fitment. This is from back when we were doing a test train split and we needed to retain consistency in word maps between our training and testing data sets. Once we have that settled, we go and we convert all of our articles into their numerically indexed values from the word map. Once we have that database, we feed them into the prefix span in order to get our sequences. However, we ran into issues specifically with memory overhead, and we had to implement a sliding window method where, given the input data, we slid a window of some length over that input, gaining sequences over an iterative period. That was done here, where we simply can figure out where we need to start the window and where we need to end the window, and iteratively work through that, each iteration gaining a set of tuples which contain the unique sequences and their frequencies. However, since we are only feeding a single article, a single portion of an article at a time into prefix span, we will only ever have min_1, as the number of transactions is only ever equal to 1. Here we can see at article 309 there are over 6,000 words, and so the sliding window is very effective in keeping our memory footprint low while retaining some decency of speed. Once we've obtained all of the sequence tuples, we strip them out, just the sequences, into a string format for which we can put into a map, or in this case a set in Python, which is done using the join operator to join all the strings together, and then it's stuffed into the sequences like so. Once we have all the unique sequences, we go and we build another mapping so we have all of the unique sequences for the entirety of our data set. Once we have that entire data set, we again go and check to make sure that if we are doing a test or train, if we need to retain that for later. Once we've got those, we go ahead and we build up our vectors. Vectors are required for the machine learning classifiers that we used. This is done simply using a database of keys matrix, which is a style of sparse matrix, which we can use to preserve memory, because as we will note later, while we may only have 11,552 unique words, our vector lengths will be much larger. For each vector, what we need to do is map the occurrence, whether a single sequence that we have come across and put into our sequence map occurs in the associated article or not. So that's to say, if some sequence occurs in an article, then that point in the vector related to the article will have a 1 or 0 representing its existence. Once that's all said and done, everything is returned back to main. So here in main, we go through, we grab our initial data, start some counters, set up some scoring for the machine learning things. We can either run a bag of words representation, otherwise we run our sequential approach. And this is where we entered that function. Moving along, we do scoring of both Bayes and SVM at the same time, because our testing has shown that generating our sequences, which is still continuing, may I add you, takes the longest amount of time. So in order to preserve as much of our computing power as possible, we decided to run both machine learning algorithms, one after the other, on the original sequences. The original sequences that had been converted into vectors. So here we see now we are creating the vectors from, this is a total of 1,467,451 unique sequences found in 500 articles over 11,000 words. Once we have done our complete machine learning algorithm things, we've let them run through, we calculate the end of our timers, and we simply print. All of our data was then taken and put into a Google spreadsheet, whereupon we were able to agglomerate all the data for several different runs. Here we can see max sequence size. This is a variable from the prefix span function. What we can limit the size of sequences we want outputted from prefix span. Also here we have another variable, window size. This tells us the size of our windows that we will use in that sliding window. Down here we can see that now both of our native Bayes and our SVM classifiers have finished and done their classifications and printed it all into a nice table. That took that took 382 seconds, or about, quick maths were never my strong suit, 5 minutes. Once we had all of our data inputted into the spreadsheets, we simply made some graphs, beautiful pictures for accuracy, the run times, and the F1 values. They were then stored and spoken about in the associated project article. One thing we kind of glossed over at the start was our data cleaning. So in order to reduce the input data set as much as possible, we had to sanitize the input. This was done in this program here, which we built by ourselves. Again, Purell, we sanitize with it. So all it does is it goes through each article, and for each article, it removes all leading and trailing white space. It removes all uppercase, replaces them with lowercase characters, and then it takes all non-ASCII numeric characters, alphanumeric characters, and removes them from the article text before putting it back. Finally, we do some stemming. This is a natural language processing technique wherein stem words are brought back to their root. We speak about this in the article. So for instance, these words here, writing, writes, and written, would all get converted to write. We have a larger example here, which can be seen. And then on top of stemming, we also perform the removal of stop words. Stop words, as indicated in the text, are connecting words that had no context, such as a, be, example, or the. So we go through every word in the article text, so long as that word does not exist in the English stop words set. Then we stem the word, add it to an array, to which we put back in string form into the article texts. In order to use our original data sets of the fake news AMT and celebrity data sets, they came in the form of this, where they were broken up into their two literal domains. Each one had a folder for all of its legitimate news and a folder for all of its fake news. Each news article was indexed as such, and each article on the interior simply looked as a title followed by the article. In order to make this work, we had to take and create a CSV that followed the title, text, and label. The folder structure determined the label of the individual article. So in order to get these into a working CSV, we had to create a very simple script that simply took all of the files in this folder structure, removed all unnecessary letters. We found that there were non-UTF-8 characters that had to be cleaned out, and then it would simply go and create a row in our output CSV for each file that conformed to the appropriate CSV headers. Thank you for joining me. I hope you enjoy our article. It was a lot of fun to write, and we definitely did not stay up all night getting it done.